Hello, everyone, and welcome to the introduction to limits. Before we begin, I would like to tell you or show to you what are the topics involved in this subtopics rather, subtopics involved in this topic. So first, yeah, we will talk about the introduction. Then next, of course, the limit of the function. Then this subtopic, it has the, let's just say, I'm not gonna say subtopics, okay? Rather, what's the correct way to say here? Parts, I guess. Yeah, three parts. Yeah, it has three parts. First part, evaluation by tabular form, evaluation by graphing, one-sided limits. The next subtopic, limit laws, and these are the parts of limit laws that we're going to discuss: basic limit laws, limit evaluation methods, squeeze theorem, trigonometric limit laws, not trigonometric limits. Forgive me. Okay, infinite limits, infinite limit at infinity, continuity, and intermediate value theorem. All right. Although there's actually one topic that I would like to include here, which is the precise definition of limits. Like, how do we really define limit precisely? But uh, what do you call this one? That would be a different topic. Okay. I mean, no. Forgive me. It's part of limits, yes, but that topic it involves more on proving. Okay. So maybe what do you call this one? I'll be, let's just say, uploading that video with that's precise definition of limits, yes, but that would be let's just say after I upload differential calculus or integral calculus, or maybe in some other time. All right. So that is all. All right. So these are the topics, subtopics, I mean, involved in limits. So let's start first with the introduction. I'll be using Desmos application, okay, so that I can visualize to you why we need to learn limits. Okay, I'll be using the Desmos application. Though I would like to uh, recall something. Okay, do you know slope or m? Usually, slope is basically the change of y all over the change of x, which is basically y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay? Remember this one, okay? Because we're going to apply that in our do you know what I mean by second line? Second line is basically a line that intersects a curve at 2 points only. Okay? So for example, I have this weird oblong curve and there's this line that intersects at 2 points. So that is second line. And last but not the least, we call tangent line. What is tangent line again? Tangent line is basically a line that intersects at 1 point. So this is what? Tangent line. Okay? This is what? A line that intersects 2 points. So the curve is second line. Okay? And what's this again? Slope. All right? So now let's use Desmos application. Okay? All right, so here we go. We have a graph of y is equal to x. All right, we have a graph of y is equal to x. So let's just say a yellow point and green point. And you have this line here. I want you to find the slope of this line. Okay, so slope of the line is basically the formula I already showed to you earlier is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, right? So let me show to you the coordinates. So just say that the green point has the coordinate of 5, 5, and the yellow point has a coordinates of 1, 1. I want you to find the slope. Okay? So what's the answer for this one? The answer is 1, right? So let me check. The answer is 1. Okay? This is basically the formula of the slope, but in a different way. Okay? But still the same. So yeah, the formula is 1. Now what if I would put the yellow point here? negative 10. Then this one, let's just say closer to it. All right, it has decimal points. What's the answer? The answer is 1. It's still 1. If I'm going to put here and this one further, okay, I have 16.8, 16.8, negative 15.2, negative 15.2. What's the answer? The answer is it's still 1. So what does it imply? It implies that your slope is actually constant. Meaning, if you're going to put the points here, points there, what's the answer? It's still 1. Put it here, exactly 0, 0. The answer is still 1. So there's no changes. So it is constant. You see, this is a linear graph or a line graph. And in a line graph, they have their own slope, right? If you recall in your algebra, you have a slope and a y-intercept, right? So that's basically the graph of a line. But you see here, we know the slope, all right? And in every line, it has its own slope, a constant slope. Let me change. Let's just say we have 2x minus 1. The y-intercept here is negative 1. So which makes sense because the line intersects at negative 1 at the y-axis. So that's a y-intercept. But you see, let's find the slope here. If I'm going to get the slope with these points, the answer is 2. If I'm going to put it here and get the slope overall, the answer is still, put here closely, the answer is still 2. So in other words, a line has its own slope. And if you're going to get the slope, you can get a point that is close to another point, or rather further away from the point, because you see these 2 points, no matter how far they are, the answer is still the same. All right, this one will result to 2. This one will result to 2. So the slope is still 2. So that's for the linear. But how about if it's non-linear? All right, like this one, for example. You see this? Wait. Yeah. So you see this? This red curve is not, how should I say this? Linear. It's a curve, obviously. Okay. Let me just change the color of that blue point here. Let's just say I will make it to a yellow. All right. So this one, I'll change it into blue. Okay. So yeah. Let me just put the labels. Let me just put the labels, the coordinates of the yellow point and the green points. The green point. So let's find the slope. If we have this, sorry, if we have this purple, what's this purple line here? Okay. So with this purple line, I want to find the slope of each of the points of the curve, So by doing that, like let's just say, for example, I want to find the slope of the curve at this point, like here, at this point. So how will you get it though? Okay. So I will try to use second line. So let's observe what's that again? The slope of the second line. If the green point is here, what happens? It's 0.21, right? Now let's make it closer to this yellow point. What's the answer? 1.35, right? Now let's make it even closer. It's 2.64. Make it closer. 3.22. Make it even closer. 3.65. Make it even closer. 3.84. And make it even closer. 3.95. So what did you observe with this line? We start from here, right? Which is a second line, right? We start from here. Okay, by estimate, we start from here. So what happens to the second line when the green point approaches to the yellow point? So from here, going here, what happens to the line? Is it already second? Like, like when we zoom in, does it already look like second to you? The answer is no, right? It looks like a tangent line because it looks like that this line intersects a one at one point, right? It looks like. But when we zoom in, nope. It looks like 2 points, right? Like this. You see this? It's still 2 points. You get me? So that means it's still a second line. But okay, what was I trying to find earlier? Let's find the slope at this point, right? At this yellow point. So what if I want to find the slope at this yellow point? The answer is undefined. Why though? Why is it undefined? Okay, why? You know the formula, right? Y sub 2 minus Y sub 1, X sub 2 minus X sub 1, right? Try to use these coordinates to find the slope. What's the answer? The answer is what? All right, let me just type it here so that you guys won't be confused. Let me just copy this one. All right. So let's just say that this is the first point and this is the second point. Okay. So the yellow point, the coordinates of the yellow point is 2.02, 4.08. The coordinates of the green point is 2.02, 4.08. Okay? So the second point is green point, right? And the first point is the yellow. So the twos, the term that has two is for the green points, while for the ones is for the yellow point. Okay? So let's start with this one. Okay? The y sub 2 of the green is 4.08. All right? Then the y sub 1 of the yellow point is 4.08 as well. Now, a sub 2 is your 2.02, right? 2.02. And here, what's the answer for What's for the a sub 1? 2.02. What's the undefined? Right? Undefined. Because this one will lead to 0 if your numerator is 0. Because you can divide you can divide by any number. You can 0 below, like on the denominator, it's invalid. Why? Because you cannot divide by 0. That would be. So what's the result? The result here will have 0 all over 0. So your slope is undefined, invalid. In fact, what you call this one, this 0 all over 0, this is what you call indeterminate form, right? Forgive me if it's, how should I say this? Forgive me if there's some spaces, but I hope you get what I mean. It's indeterminate form, So to answer your question, it's not possible to find what? To find the slope exactly at one point, because you see, it becomes undefined. You know what I mean? It becomes undefined. But here's the thing though. Here's the thing. Okay? Let's give it a chance. Okay? Yeah. Look at this one. We start from here, then we go from here and here and here, right? Okay. Now here's the thing. When you zoom in, what do you see? It looks like a tangent line because you see it what? It has 1 point, intersection, right? So it looks like a tangent line, But when we zoom in, when we zoom in, zoom in, zoom in, zoom in, and further and further and further, they're actually this very far. You get me? They're actually this very far. All right? So that means we can get the slope of the tangent not exactly, but what? But by estimate. Like this, right? You see, you can get the slope of this this one, like for example, exactly this, right? That's impossible. Wait. Yeah, that's impossible, right? You can. But if we make these points closer together to the point that it looks like they are being overlapped with each other, or they look like at one point just like this, but in reality, it looks like they're like this close together, then we can get the slope. All right, we can get the slope. Do you understand? We can get the slope. Not exactly, but by approximate or by estimate, we can. All right. Another example is like this. Oh, another example is like this. Wait. This one. Another graph. You see this? Okay. Let me just change the color of my points. Okay. This shall be green and this shall be yellow. Okay. And yeah, I think that's already okay. So how about this one? Let's just say at this peak of this curve, at this peak. Okay. Let's find the slope. Well, of course, if we're going to put yellow point and green points here together, what happens? It became what? It became what? The slope here is undefined. Okay, it's undefined. Okay, you can't. But if we make it as close to each other, you know, to the point that when we zoom out, it looks like it's a tangent line. You know, it intersects at one point, but in reality, they're just actually as far just like this. You know, so we can get the slope. We can get the slope, not exactly, but as close as we can, as you know, as we can, you know, like approximate it. So we cannot get the slope of the tangent line exactly, but by approximate, we can. Just like how we view it at the bigger picture. Okay? So now let's go back to the PowerPoint. Where was I? Where was I? Was that? Yeah, wait. Let me just pause for a moment. All right. So now let's back here. Let's go back here. So here, what did you observe? As the green point approached the yellow point, am I right? Oh yeah, it's just the same thing. You get me? As the green point approached the yellow point, we were forming a tangent line, right? You notice that? And I told you that it is impossible to exactly find the slope of the tangent line in a curve, since having these points in the same position will result in an undefined answer. But by approximation, we can find its slope by making these points closer as if we want them to overlap, but they actually don't. Okay? Closer as if we want them to overlap, but they actually don't. So in other words, it's all about approaching. It's approaching, okay? Not making them overlap. All right? So take a break for a moment, then we can now proceed to the next video. See you soon.